shipping for quite a while. Some others are in the making. This makes us the most active investor in crowdfunding hardware startups, which actually were more of the cause rather than the consequence here. Today, I encourage you guys to go actually on Kickstarter /Accelerator because we have a few companies that have launched yesterday, some of which are going to launch today or in the coming days or weeks. So you can follow this page. Encourage you to back them, of course. And on Twitter, if you want to refer about the event today, just use the hashtag hacks. We're also live streaming for those not of you, but the other guys who are not here today, unfortunately. But you can send that link. So youtube.com/Hackcelerator for those who want to see what's going on today. We have 10 startups. Most of them are going to do about 5-minute pitches, and then we'll go on to having fun with them at their booth, and lots of robotics, consumer devices, in education, in sensors, and a lot of very exciting things coming up to the market. And essentially, without further ado, I'd like you guys to welcome the first startup that is going to present today. That's Ira from Vertora.
Thanks, Cyril. So everyone's here today because of these amazing hardware companies, but building hardware sucks. It sucks so much that every company in this room moved to China to be able to work faster. One of the biggest problems that we all faced was circuit board prototyping. Circuit boards are found in every electronics product, from your toaster to your smartphone. Factories around the world spit out tens of thousands of them every single day, which is great for mass manufacturing. But earlier in the development cycle, when you just need a couple boards for prototyping, it's an absolute nightmare to deal with. Most designers outsource fabrication to a facility in China, pay a couple $100s, and wait 2 weeks for delivery. When the boards finally arrive, they realize that they made a mistake. So now they pay a couple $100s and wait 2 weeks again. In that time, the product requirements have changed. So now they're back to waiting for weeks and on and on. A while back, I was working on a do-it-yourself project and decided to just make the board myself. I had barely gotten started before I got kicked out of the house because as a hobbyist on a budget, the only way I could create that circuit board was a tedious etching process that required toxic and corrosive chemicals. We spent the past year building a better solution, a printer that can create a circuit board in the time it takes to go get lunch. A user can design their circuit in whatever software they're already comfortable with, and then just press print. Our technology uses a silver nanoparticle conductive ink, and we're also the first in the world to be able to print multi-layer circuits. The printer will be launching early next year, and will also generate recurring revenue through replacement ink cartridges and substrates. So far, I've only really talked about circuit printing, but it's important to note that we've also built in a solder paste dispenser and a reflow oven, which solves 2 other huge problems our customers have later in the development cycle. We've essentially combined 3 tools into one, and as a result, the cost and time savings are staggering. But let's take it a step further. If you owned a business, how would you feel knowing you were paying your engineers to wait for the FedEx truck rather than building product? We live in a world where a company's agility determines its success. So to us, the choice between lead times of 2 weeks or just 60 minutes is an easy one to make. Now, I'm not saying that printing prototype boards is as difficult as skydiving from the stratosphere. But until very recently, both of these were considered to be impossible. This is the first time anybody can print a functional and truly useful circuit board. We've talked to many industry experts who doubted that it was even possible. But we overcame complex chemical limitations and proved that we can rapid prototype electronics. The rapid prototyping market is expected to quadruple in the next 4 years. Now, this started with 3D printers, but with the growing demand for electronics from the maker movement, hardware startups, and the Internet of Things, we believe that circuit prototyping is going to drive this trend. And it's not just market reports that are backing us up on this. We've talked to engineers from large tech companies, hardware startups, and the academic and hobbyist community. They all agree that hardware developers need a faster way to prototype electronics. But more importantly, they were so excited about what they can do with this new freedom. A professor from our old university wants to print experimental RFID tags and antennas. Our friends from other hardware startups would have used this to get to their minimum viable product much faster than before. We've talked to electrical designers that want to put our product beside their 3D printer for truly rapid prototyping. And the makers, they just want to build cool stuff with custom Arduinos and Raspberry Pis. We are a team of passionate engineers that have been classmates, teammates, and roommates over the past 5 years. We met at the University of Waterloo while completing our mechatronics and nanotechnology degrees, which have been essential for building a product this mechanically and chemically complex. We just spent 4 months living in Shenzhen, China, the electronics capital of the world. And even there, the fastest that we could get a board turned around was 2 days. Our printer needs less than 2 hours. So with Volterra, if you need custom circuits, just press print. Thank you.
Hi, I'm Nils with Firm, and this is not my home. But you can tell that whoever lives there cares a great deal about it. And we all do. Our homes are places for the people and things that we love, places we feel a special connection to. Yet, when we're away, we sometimes feel disconnected. We want to know that everything is fine at home. But so far, our only options have been cameras and invasive security systems. It shouldn't have to be like this. Who wants a camera at the dinner table? At Firm, we're pioneering a new approach. We call it soft security. Our first product is Point. Point is a smart house sitter. It combines sensor data with sound data to tell you about the things you care about in your home. Here's a short introduction video.
It's a smart house sitter. It lets you know if anything is wrong at home. Point can identify sounds like alarms or windows breaking. It can sense smoke and other airborne hazards. You set your own rules for how you want Point to respond to events. For example, it can light up if there is a loud noise late at night. Point is simple and unbranded, allowing it to blend into any home, anywhere. It's a softer approach to home security.
Point comes with many different sensors, but it's not the individual data from any of the sensors that is interesting. It's when you combine the sound of breaking glass with fluctuations in temperature that you know that a window truly broke. Point tells you about what happened in your house in a timeline, so allowing you to stay connected when you're away. And you can set it up to tell you about the things that you care about, because all of our homes are different. We designed Point because we wanted it in our own homes. And in the process, we found